Okay, so we're starting with the 7.2 page of the review. The first one says solve by substitution, so we already have y isolated, so we're going to use that, and then substitute it into the first equation. So we have 2x minus 3 times 2x plus 7 equals negative 13. We're going to then distribute that negative 3 with negative 13. We're going to combine our like terms, which involves adding the 21 to the other side. 21 minus 13 is going to give us an 8. Over here we have negative 4x. We're going to divide by negative 4. Gives me x equals negative 2. Now that we have the x equals negative 2, we're just going to substitute it back into our y equals 2x. Now we know our value of x plus 7 equals 3. And then remember, we write our answer as a coordinate point. So we have negative 2, 3. That's our first solution. We're going over the second one that has the same directions. So now we just have to isolate a variable. Looking at this, we see the second equation is the easiest one to isolate for. We can rewrite that as x equals 6y minus 8. And now we're just going to substitute that back into the first equation. We have 2 times 6y minus 8 plus 5y equals 1. We get 12y minus 16 plus 5y equals 1. Combine our like terms, we get 17y equals, we're going to add that 16 to the other side. So we're going to get 17, divide by 17. We see y equals 1. Now that we have y equals 1, we're going to substitute that back into the equation we already solved for x. So we have x equals 6 times 1 minus 8, which equals negative 2. So our answer is going to be negative 2, 1. The next two are solving by addition, or we also call that the elimination method. So we need to get each variable, how do I want to say that? We need to get one of the variables to have the same coefficient in both equations, both opposite signs. So I took the second equation and multiplied it by 7, which gave me 2x minus 7y equals 2. And we have 21x plus 7y equals negative 140. We're going to combine our like terms. We get 23x. The 7's are eliminated. And we end up with negative 138. Divide by 23. Divide by 23. X equals negative 6. Now we're going to take that negative 6 and we're going to substitute it back into one of the equations. So we have 3 times negative 6 plus y equals negative 20. We end up with negative 18 plus y equals negative 20. Y equals negative 2. So you see our two variables, and then we're going to write them as negative 6, negative 2. And then 4, again, is an elimination method problem. And with that, we're going to try to eliminate a variable. I took the first equation and I multiplied it by 3. I took the second equation and I multiplied it by 4 to eliminate the y's. So I end up with 9x minus 12y equals 33. And I get 8x plus 12y equals negative 16. Combine like terms, we get 17x equals 17 divided by 17. We see that x equals 1. Now that we have that value, we can choose either of the original equations, substitute it in. So if we did 2 times 1 plus 3y equals negative 4, we get 2 plus 3y equals negative 4. I said 4. I'm going to subtract the 2 to the other side. We get 3y equals negative 6, divide by 3. Y equals negative 2. And again, we write this as a coordinate point. And that's our first page. Okay, so now on to page 2. I have 3 equations. Our 3 equations are 1, 2, 3. And now we are going to solve to try to eliminate one variable from all of the equations. And so remember, we have to start with 2 equations, and then we use the third equation with one of the other 2 equations to eliminate that same variable. So I'm going to try to eliminate x, and this is going to be convenient since we have the equation 3 that has just an x with the coefficient of 1. So I'm going to take equation 1, EQ1, and then I have negative 2 times EQ3, which gives me 2x plus y minus 2z equals negative 1. And I get negative 2x plus 4y minus 6z equals negative 12. Combine like terms, we're going to get 5y minus 8z equals negative 13. And this is going to be EQ4. And then we're going to take equation 2 and equation 3. We'll take EQ2 and then negative 2 times EQ3 to eliminate that same x variable. So for my equation 2, I get 3x minus 3y minus z equals 5. I have negative 3x plus 6y minus 9z equals negative 18. We end up with 3y minus 10z equals negative 13. This is going to be equation 5. So now we are down to 2 variables. Now to eliminate the final variable, to solve for the last one, we want to use equations 4 and equation 5, and we have to decide on a variable to eliminate either y or z. So I chose to do 3 times equation 4 and negative 5 times equation 5. And this gives me 15y minus 24z equals negative 39. And then over here we have negative 15y plus 50z equals 65. This gives me the y's cancel. We get 26z equals 26. Divide both sides by 26. We see that z equals 1. Now that we have that value, we can substitute that back into one of the equations, either 4 or 5, because it's already down to 2 variables. So I'm going to go to equation 5. And so with equation 5, we have 3y minus 10 times my value is z equals negative 13. I'm going to add 10 to both sides. I end up with 3y equals negative 3. Divide by 3. Y equals negative 1. Now that we have a z and a y value, we're going to continue on over and then substitute into our last part. And so I chose equation 3 to do this with. And so in equation 3, we have x minus 2 times negative 1 plus 3 times 1 equals 6. X plus 2 plus 3 equals 6. X plus 5 equals 6. X equals 1. I have to subtract that 5 over. And then remember we write this as an ordered triple. So our answer is going to be 1, negative 1, 1. That's our ordered triple solution. Then we have one more like this. Again, we have 3 equations. we have equation 1, equation 2, equation 3. I'm going to take equation 1 times equation 2, and I'm going to eliminate that y. We see that we have a negative y and a positive y in those two equations, and so it's natural when we add those, so that's just going to drop out. I don't have to do anything else with those two equations. So I have x minus y plus 3z equals 8. We have 3x plus y minus 2z equals negative 2. We get 4x plus z equals 6. So this is going to be my equation 4. I'm going to box it in so I can find it when I need it. Going on from there, I'm going to use equation 3. And I also want to eliminate that y variable because that's why I eliminated it in the first group. So to do that, I'm going to take equation 3 and then 4 times equation 1. And I'm doing 4 times equation 1 because equation 1 already has a negative y. And so this gives me 2x plus 4y plus z equals 0. Over here, I now have 4x minus 4y plus 12z equals 32. Now we're doing that addition method, so we're going to add them together. We get 6x, the y's cancel, plus 13z equals 32, and this is going to be my equation 5. Now, using equation 4 and equation 5, I want to eliminate my next variable. So I'm going to use equation negative 13 times equation 4, and then equation 5. So this gives me negative 52x minus 13z equals negative 78. Then we have 6x plus 13z equals 32. Combine like terms. We add down, we get negative 46. X equals negative 46 divided by negative 46. And you can see that our x value is going to be 1. And then we take our values that we have, we substitute them into one of the original equations and solve for the remaining variable, which is y. So if I took equation 1, EQ1, I'm now going to sub in, I have 1 minus y plus 3 times 2 equals 8. I have 1 minus y plus 6 equals 8. I have negative y plus 7 equals 8. And then I'm going to subtract that 7 over. I get, I'm going to go this direction, guys. Negative y equals 1. Y equals negative 1. And then our last step is going to be just writing that as our ordered triple. So once again, when we write this, we have our x value as 1, negative 1, and 2. So on to page 3. We now see that, again, it tells us just to solve a two-variable system of equations. We can choose any method we'd like. So you could do it graphically. You could do it with elimination or substitution. I prefer elimination, so I'm going to take 5 times EQ1. So we have EQ1, we have equation 2. So 5 times EQ1, and that's going to give me 10x minus 25 y equals negative 75. And then I'm going to take negative 2 times equation 2. And that's going to give me a negative 10x plus 6y equals a negative 58. The x's eliminate. I get a negative 19y equals a negative 133. Divide by negative 19y. Not the y part. Divide by negative 19. Y equals 7. Now we take that 7, we substitute it back into one of our original equations. So substituting back into one of those original equations. I chose equation 1. We get 2x minus 5 times 7 equals negative 15. 2x minus 35 equals negative 15. We're going to add 35 to both sides. We get 2x equals 20. X equals 10. So our final answer is going to be that ordered pair of 10, 7. Number 2. It seems natural to want to eliminate the z's first. When I did this, that's not what I did, but you're welcome to do it that way. I decided I wanted to eliminate the y's. So 1, 2, 3. With this, I took equation 1 and equation 2. So EQ1, EQ2, and then I just added them. So I have x plus y plus z equals 2. 2x minus y plus z equals 7. I end up with 3x plus 2z equals 9. This will give you my equation 4. And then I have to use that third equation because I haven't used it yet. So I have equation 2 times equation 2, and then EQ3 to try to eliminate that y variable as well. So I end up with 4x minus 2y minus plus 2z equals 14. We have x plus 2y minus z equals negative 6. We have 5x, the y's eliminate, plus z equals 8. And now I have a fifth equation. I'm going to use equations 4 and 5 to try to eliminate another variable. I'm going to try to eliminate z. So let's switch this up. Okay, so now I have negative 2 times equation 5 and equation 4. This is going to give me negative 10 x minus 2z equals negative 16. I have 3x plus 2z equals 9. Negative 7x equals negative 7. Divide by my negative 7s. X equals 1. So we now have z. Oh, nope, we just now have x. And now we're going to substitute it back into equation 4 or equation 5. So if I take it back to equation 5, I have 5 times 1 plus z equals 8. I'm going to subtract 5 to the other side. Z equals 3. Now I know 2 of my variables. I'm going to finally try to solve for that last one. I can take any of my first 3 equations. So I'm going to substitute into equation 1. So EQ1. And inside equation 1, I have 1 plus 4 plus 3 equals 2. I get y plus 4 equals 2. Subtract 4 over. Y equals negative 2. So we have 1, negative 2, 3 is our final answer. Let's finish that parenthesis. And then again, the last one on this page is that partial fraction decomposition. So our first step is to set up the original fractions. You notice that they are all linear, and then they cannot be broken down any further. So we're just going to have 1 degree less than linear is what goes in the numerator. So my fractions denominators are going to be x plus 2 plus x plus 1 plus x minus 1. And then 1 degree less, so I'm just going to have a, b, and c. Since these are all linear, constant terms, what's above it? So we have our least common denominator, our LCD, which equals the original denominator, x plus 2, x plus 1, x minus 1. I'm going to take this and I'm going to multiply both sides of the equations by it. When we multiply both sides of the equation, on my left-hand side, I am left with just the numerator of that fraction. So we end up just with that 10x squared plus 9x minus 7. And then when we multiply to the other portion, our other side, we end up with equals. So in our first fraction, we see that the x plus 2 cancels with the denominator and now the LCD. So we end up with just a times x plus 1, x minus 1. And then we're going to have plus our second fraction is that b, the x plus 1 is in the denominator, so it's going to cancel with that LCD. And we're going to have b times x plus 2, x minus 1. And then our last one is going to be c, and the x minus 1 is in the denominator. And so we're going to cancel with the x minus 1 in the LCD. So we're left with that x plus 2, x plus 1. Now we're going to distribute these out. So the right side stays the same. Or not the right side, the left side stays the same. So I end up with that 10x squared plus 9x minus 7. And then when we distribute this out, I end up with x times x squared. Or to x times x is x squared. So I get an ax squared. And then you have a plus 1x minus 1x. So those terms drop out. And then we have 1 times negative 1, which is going to be a negative a. Our next one's going to be the b terms. Let me switch back to that pink. And we see that when we multiply this out, we get x squared plus 2x minus x minus 2. Combine my like terms. So I bring it down here. I'm going to have plus bx squared plus, and then 2x minus 1x is just going to be bx minus 2b. And then the last part is that c. And so with c, we get x squared plus 2x plus x plus 2, which brings me to cx squared plus 3cx plus 2c. Now that we've reached this portion, we're going to now rewrite our left-hand side vertically. So we end up with that 10x squared, 9x minus 7. And then we're going to group our terms that belong in each category. So I have equals ax squared equals negative a. Then we go on to the pink section. I have plus bx squared equals bx minus 2b. And then our last group is the c section. And I have, let's erase that, cx squared trying to move that screen. I keep drawing. And we have a plus 3cx. And then we have a plus 2c. Okay, I'm going to draw a line to make sure we separate our new system of equations. I'm going to rewrite all three of these so that we can now, if they have, all of them have x squared in them, the x squareds can go away. If they all have x in them, all the x's can go away. So now we're going to have equation 1, which is going to be 10 equals a plus b plus c. We have equation 2, which is 9 equals b plus 3c. And we have 3, which is negative 7 equals negative a minus 2b plus 2c. As you know, I'm going to need more space, so I'm going to take my work up here. So I'm going to use equation 1, EQ1, and EQ3. So equation 1 gives me 10 equals A plus B plus C. And equation 3 tells me it's negative 7 equals negative A minus 2B plus 2C. We get 3 equals negative B plus 3C, and this is going to be my equation 4. So the reason we did this is because we know that equation 2 is in terms of B and C, so we had to eliminate the variable A so that we could end up with variables B and C being what's left. So now that we have equation 4, now we're going to use equation 4 and equation 2, and we're going to eliminate the remaining variables. We see naturally that that's going to occur because there's a plus B in equation 2 and there's a negative B in equation 4. So EQ2, EQ4 gives me 9 equals B plus 3C. And we have 3 equals negative B plus 3C, which gives me 12 equals 6C, C equals 2. Since we divided that 6 over, now that we have C equals 2, we're going to substitute it back in to either 2 or 4. So I went with 2, 9 equals B plus 3 times 2. 9 equals B plus 6. Subtract the 6 over. B has to equal 3. Now that we have the B equaling 3, we're now going to have to find A. So we take any of the original equations. Obviously 2 is not going to work because there's no A in it, but the other remaining ones. So we have equation 1 is what I'm going to use. So we're going to go from here over here. So with equation 1, I end up with 10 equals A plus 3 plus 2. We're going to combine our like terms. 10 equals A plus 5. Subtract 5 over. 5 equals A. Remember, we're never done until we substitute it back into our original fractions we made up. So with doing that, our final answer will be 5 over x plus 2 plus 3 over x plus 1 plus c over x minus 1 being our final answer. On to our last page. So again, for number 4, our first step is to set up those fractions. So we look in our denominator and we see that we have a factor of x, and then we have a factor of x plus 7, which is repeated. So remember, when we have repeated factors, we have to account for both of them. So we have an x plus 7 in our first one, and then our second one we have is x plus 7 quantity squared. All of the original factors are linear, so that means constants are what goes on top. So we're just going to have A, B, and C. Now that we've done this, we need to identify the LCD. The LCD is going to be the original denominator. We're going to multiply both sides of the equation by that. When we multiply it by the left-hand side, the denominator drops out, and I'm left with just that 3x squared plus 49 equals, and then we're going to multiply by the other side. So the x cancels with the x in the LCD, so we're going to have a times x plus 7 squared. And then we'll have b times x plus 7. Because one of the x plus 7's cancels. And then our last one is going to be that c. And it's just going to be times x. Because the x plus 7 quantity squared cancels with that in the LCD. Now we see that we need to distribute this out. So this is going to stay 3x squared plus 49. And then over here, we're now going to have, this becomes x squared plus 14x plus 49. If you need to FOIL that out, you are welcome to. But ax squared plus 14ax plus 49a. We're going to do the same thing with b. We can do this as we go. We know that this is going to become x squared plus 7x. So we get b times x squared plus 7bx. And then again, the last one is easy enough. It's just going to be cx. We're going to write our original vertically. So we're going to have 3x squared. We don't have an x term, so we represent that by 0x. And then 49. We're going to place what belongs in each of them next to that. So x squared term, I have is ax squared. We also have a 14ax. And we have a 49a. We're going to move to the b terms. So we see that we have bx squared plus 7bx, and then we just have one last cx. We can rewrite these as our systems of equations. We can drop out all of the ones that have, if all variables have an x squared with them, we can see that we have 3 equals a plus b is our first one. 2 is going to be 0 equals 14a plus 7b plus c. Let's put that plus sign up here that I forgot. And then down here we have equation 3, which is just going to be 49 equals 49a. Can't handle it. Give me one more second. 49a. Which we know that means a equals 1. Now that we have a equals 1, we can bring it to equation 1. And we get 3 equals 1 plus b equals 2. And then our last step is to solve for c. The only one that has c in it is equation 2. So we're going to take equation 2 over here. So we get 0 equals 14 times 1 plus 7 times 2 plus c. 0 equals 14 plus 14 plus c. We have 0 equals 28 plus c. We're going to subtract that to the other side. We get negative 28 equals c. Now our last step is to take this and put it back into our original. So our original now becomes 1 over x plus 2 over x plus 7 minus 28 over the quantity of x plus 7 squared. And our last one. So again, we now have to write out our original factors. We see that our denominator has an x plus 3, and it also has an x squared plus 4. We see that x squared plus 4 cannot be factored any further. It is prime. So our first one's linear, so what goes above it is 1 degree less. That's that constant. And then over here we have x squared plus 4, which is prime, but is a prime quadratic, so we put a linear above it. We represent linear equations by that slope-intercept form, y equals mx plus b, so this is just going to be bx plus c. We have our LCD, which is that original denominator, which is going to be that x plus 3, x squared plus 4. We multiply both the left and right-hand sides of the equation by this, and we end up on the left-hand side with that x squared plus 4x minus 23 equals, over here, it becomes a times x squared plus 4 because the x plus 3 cancels with the LCD, and then our next part is going to be that plus bx plus c times, and then x squared plus 4 cancels with the LCD, and what remains is that x plus 3. We're going to multiply this out, so we get x squared plus 4x minus 23 equals ax squared plus 4a. And over here we have plus bx squared plus cx plus 3bx plus 3c. So we just did again the distributive property to arrive there. We're now going to regroup. So I'm going to take my left-hand side and I'm going to write it going down. So I have x squared, 4x, negative 23. And then we have equal, equal, equal. Group what we have. So over here we're going to end up with ax squared plus bx squared. Then we end up with cx plus 3bx. And then we have 4a plus 3c. Again, if all of them have the same thing in it, you can take that out. So we can rewrite each of these. So I have 1 being 1 equals a plus b. We have 2, which is 4 equals c plus 3b. And then we have 3, which is negative 23 equals 4a plus 3c. So all of them only have 2 of the variables in it. So we're going to have to create something to help with that. So I use equation 1 and equation 2. So using equation 1 and equation 2, move over here. So negative 3 times equation 1, equation 2. Get negative 3 equals negative 3a minus 3b. And I have 4 equals c plus 3b. We end up with 1. There's no a term to go with it, so we have negative 3a. The b's cancel, plus c. This is going to be equation 4. Now that we have equation 4, I'm going to take equation 4 and equation 3 and try to eliminate again. So equation 4, I'm going to take negative 3 times equation 4, which will be negative 3 equals 9a minus 3c. And then we take equation 4. That was equation 4. We take equation 3. We bring it over. That's going to be that negative 23 equals 4a plus 3c. Combine like terms. We get negative 26 equals 13a. Divide by 13. Divide by 13. A equals negative 2. Now that we have a equals negative 2, we can substitute it into one of the other equations. I substitute it into equation 1. So going from here to equation 1, EQ1, we have 1 equals negative 2 plus b. We have b equals 3. Now we have 2 of the variables. We're looking for just that last one. So for our last one, we're going to take equation 2. And inside equation 2, I now have 4 equals c plus 3 times 3. I have 4 equals c plus 9. I'm going to subtract 9 over. We have c equals negative 5. And then once again, that last step is going back to the original and now substituting it in. I'm going to bring that right down here in the middle and put it in bright red. And you see that our a value was negative 2. So we have negative 2 over x plus 3 plus 3x minus 5 over x squared plus 4. Okay, hope this helped. Let me know if you have any questions or if you see any